Hello everybody, welcome to Flipped Classroom Lesson. Hopefully you are watching me in class right now or at home, doesn't really matter. But I'm going to take about the next 15 minutes and try and help you understand how to solve exponential equations. We've kind of done some of this already, but for the easier problems, where once you convert it into exponential form or vice versa, it's easily understood. But these are going to be a little bit more challenging today. You have your note packet out and available. If not, put this on pause, go get your note packet out and make it available, and then you can follow along with the notes. These are also be good notes to refer back to when practicing or studying, because you will have the full solutions. The first type of problems that we're going to try and solve are the ones that have the same base on both sides of the equal sign. So in this problem here, you can see the base is 7, and on this side here for problem number 2, you can see they both have a base of 4. And what's really easy to solve is problems that have the same base. Here's the idea that if I have x to the a and that's equal to x to the b, then that must mean that a equals b. And so we're going to take that idea and use that to solve these problems. So with problem number 1, if 7 to the 3x plus 2 is equal to 7 to the x minus 1, then that must mean that 3x plus 2 must equal x minus 1. And from there you can just do your basic algebra to solve. You will want to check when you're done just to make sure that there's nothing wrong. So subtract x from both sides, subtract 2 from both sides, and divide by 2, and I get x is equal to negative 3 halves. And I'm going to check that. Is 7 to the 3 times negative 3 halves plus 2 equal to 7 to the negative 3 halves minus 1? And that's a question. And then you can check that and see if it is the same. Go ahead and check that now. Hopefully you had enough time to check it out, and it does turn out that it works out. So our final answer is x equals negative 3 halves. Let's go ahead and try and do the next problem. Since they both have the same base, let's set the exponents equal to each other and solve. You're on your own. Hopefully you pressed pause and had a second to work it out on your own. If you did, hopefully you had an answer of x equals 1. I checked my work and it does hold true. Okay, those are the easy kinds. Now, what happens if the bases are not the same? Here you have a base of 2, here you have a base of 4. Here you have a base of 4, here you have a base of 64. So you can see in each of the individual problems, the bases are not the same as each other. However, we are going to solve these equations that we can make have the same base. Since both 2 and 4 are powers of 2, we can rewrite them both as powers of 2. Base 2. Over here, we can write these both as powers of base 4 or base 2. It doesn't really matter, your choice. Let's start with problem number 3. It's much easier to rewrite 4 as a power of 2 than it is to rewrite 2 as a power of 4. So I'm going to keep this side the same, and I am going to rewrite 4 as 2 squared to the 5th power. So this over here is saying that we have 2 to the 2nd, which is 4, to the 5th power. So that should be good. So now over here I end up with 2 to the 3x minus 4. Whoa, moving on me. That says 3x minus 4. Let me erase that and rewrite. 2 to the 3x minus 4. 2, 3, I gotta slow down is what it is. Equals, do you remember what to do with an exponent raised to an exponent? You're right, you multiply. So you end up with 2 to the 10th. Now the bases are the same. Now we can solve this by setting 3x minus 4 equal to 10. And even though we don't get a nice number, it doesn't mean it's wrong. So I get add 4, that makes it 14 divided by 3. X equals 14 divided by 3. So on number 4 over here, I need to rewrite 64. So like my little thought bubble over here is, what is 64 rewritten as a power of 4? 4 to what power equals 64? That's right, it's a 3. So I'm going to rewrite this problem as 4 to the 3x plus 1 equals 4 to the 3 to the 3x. Now they both have a base of 4. My left hand side doesn't change. My right hand side becomes 4 to the 9x. Now I can set 3x plus 1 equal to 9x and solve. You try that on your own, press pause, and when you press play, the answer will be there. How many of you got 1/6? Alright, nice job, nice job. So these are the types of problems that you can rewrite the bases as the same as each other. Now let's kick it up a notch, one more notch. Here's the next notch. It's going to include what's known as the change of base formula. Solving exponential equations that we cannot make have the same base. So 5 and 12, you can't rewrite 12 as 5 to a power. You can't rewrite 7 as 2 to a power. So all we can do is use our intuition, be able to convert, and use what's known as the change of base formula. If I have log base a of x, that equals to log x divided by log a. Now notice I didn't say a base on these, so these are presumed to be base 10. But they can be base anything that you want. Just base 10 is what our calculator will do for us. So it's generally what we choose. So log base a of x is log of x divided by log of a. So when I see this problem here, I have 5 to the x equals 12. Well, let's see, what if I convert this into log form? X equals log base 5 of 12. Some of you have the calculator that will do this. If you go into the math button and go all the way down to the log base formula, you can do this on there. Otherwise, this is just equal to log base 10 of 12 divided by log base 10 of 5. Get out your calculators and round your decimal to the nearest, let's go hundredth, to the nearest hundredth. Okay, so you can see on the calculator, you simply do log 12 divided by log 5, and the calculator will give out the 1.54, which we're claiming to be our final answer. Moving on to number 6, 2 to the x equals 7. I know 2 squared is 4. I know 2 to the third is 8. So I'm expecting my answer to be between 2 and 3, probably closer to 3. Let's convert to log. X equals log base 2 of 7. So on my calculator, I'm going to do log 7 divided by log 2. And what does that give me? Well, let's see. Log 7 divided by log 2. And that gives me approximately 2.8, which is consistent. What was it, 2.81 approximately? Is consistent with what my expectation was, between 2 and 3, but a little bit closer to 3. If you have any questions, of course, you can always pause this, rewind it, and try it again on your own, or you can wait and talk to me in class. I won't be in class. Certainly send me an email if you have any questions. And we do want to kick it up one more notch. And notice here on 7 and 8, we can't rewrite these with the same base. So all we can do is follow the same approach. So I can go 2x plus 1 equals log base 4 of 7, simply converting it into logarithmic form. And then from here, log base 4 of 7 is a decimal. 2x plus 1 equals, what is log base 4 of 7? Let's do log of 7 divided by log of 4. And you get that to be about 1.4. And we can use approximations here. It's about 1.4. Now I just have to solve this using some uglier numbers, but it doesn't change what it is. 2x, let's subtract 1. So that gives me 0.4. So x equals 0.4 divided by 2, which is 4 divided by 20, which is 0.2. So x is equal to 0.2, also known as 1/5. Either one of those will work. Now looking at problem number 8. Problem number 8. I have an exponential function. I know that because my variable is up in the exponent, but it's not isolated. I need to get the exponential part all alone. In order to do that, I must take care of the 10. So I am going to write my next step as 3 to the 5x equals 4. How did I get 4? 14 minus 10. Now I can simply say 5x equals log base 3 of 4, get my decimal approximation for log base 3 of 4, and then solve for x. You try to finish this one on your own, pause, come back and check your answer in just a moment. Okay, sorry for the calculator in the way, but I wanted to show you some of my calculator work. 5x is equal to log base 3 of 4. Log base 3 of 4 was about 1.26. You can see that over here on the calculator. I took that 1.26, divided it by 5, took my answer, divided by 5, and I got approximately 0.252. So the final answer for this problem is approximately 0.252. Hopefully you guys are following and understanding all right. You get an opportunity to practice now. And so you can either do it right now or you can work on it in class tomorrow. I will have another video for the next part of this lesson for you to watch for the next time. Hope you enjoyed this, or not. I don't know. I'll ask for some feedback when I return to school on Monday. Thanks. Feel free to email me with any questions or concerns. Thanks, Mr. Kleeman, signing off.